Class 8 Maths, Chapter 1, Rational Numbers, Introduction. If you see this figure, we'll understand natural numbers are part of whole numbers are part of integers, and integers are part of rational numbers. In our class 7, we have seen what are natural numbers, whole numbers, and integers. Now, in this chapter, we'll see what are rational numbers and how those are different from integers, whole numbers, and natural numbers. So first we'll see what are natural numbers. Natural numbers are nothing but general counting numbers. Counting numbers starting from 1, for example 1, 2, 3, 4, 5, 6 and so on. All these numbers are natural numbers. So what are whole numbers? 0 plus natural numbers are called whole numbers. That means if you add 0 to the natural numbers, this becomes whole numbers. 0, 1, 2, 3, 4, etc. So natural numbers plus 0 is whole numbers. Now what are integers? So we already know from the figure that integer contains whole numbers. So all these numbers come under integers plus negative natural numbers. Those are -1, -2, -3, -4 and so on. So all these whole numbers plus negative natural numbers come under integers. Now from the figure it is clear that integers are part of rational numbers. That means all these numbers are rational numbers only. Apart from this, we have different numbers also. Those also come under rational numbers. Now we will see what are those numbers which come under rational numbers. What are rational numbers? The word rational arises from the term ratio. When you come through a word rational, you should remind the word ratio inside the rational. So what is a ratio? Ratio is, for example, P is to Q. This is a ratio, right? So we take another example, 3 is to 2. 3 is to 2 is also a ratio. 3 is to 2 can be written as 3 by 2. Here 3 and 2 are integers, right? So this is a rational number. To generalize, let us take ratio P is to Q, which can be written as P by Q. A rational number is defined as a number that can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. P and Q should be integers. That means P and Q can be -2 by 4, -1 by 3, 4 by 8, 0 by 9, 10 by 4, -100 by 24. So all these are rational numbers. Because according to the definition, these are in the form of P by Q and Q is not equal to 0. Why Q should not be equal to 0? If we take any ratio where Q is 0, like for example -2 by 0, this is undefined. Because any number by 0 is undefined. 100 by 0, undefined. 99 by 0, undefined. Hence, P by Q, where P and Q are integers and Q is not equal to 0, only those ratios are rational numbers. Now we'll see what are the different forms of rational numbers. We'll do this by taking some examples. Let us take 4 by 9. Is 4 by 9 a rational number? Yes, because 4 by 9 is in the form of P by Q, where Q is not equal to 0. Here both 4 and 9 are integers. So 4 by 9 is a rational number. Is -3 by 4 a rational number? Yes, because -3 by 4 is in the form of P by Q, where -3 and 4 are integers and 4 is not equal to 0, that is Q is not equal to 0. So -3 by 4 is a rational number. Similarly, is 25 a rational number? Of course, because 25 can be written as 25 divided by 1, where this is in the form of P by Q, where P is equal to 25 and Q is equal to 1, where 25 and 1 both are integers and q is not equal to 0. Hence 25 is also a rational number. Any number which you can write in the form of p by q, only condition is denominator should not be equal to 0, then that number is a rational number. There are another type of rational numbers. Now we will see what are those. Till now we have seen rational numbers in the form of fractions. Now we will see rational numbers in the form of decimal number. For example, 0.5, 2.3, 0.333. Are these rational numbers? Yes, because 0.5 can be written as 5 by 10, where 5 by 10 is in the form of p by q, and p is equal to 5 and q is equal to 10 and q is not equal to 0. So 0.5 which is equal to 5 by 10 is a rational number. Similarly, 2.3. 2.3 can be written as 23 by 10. This is in the form of p by q. So this is also a rational number. 0.333. This can be written as 333 by 1000. So this is in the form of p by q, right? So this is also a rational number. You take minus 6.9. This can be written as minus 69 divided by 10. So this is in the form of p by q, where p is minus 69 and q is 10. Both are integers. So minus 6.9 is also a rational number. Now we'll go back to the figure which I shown you in the first. So we know that natural numbers are 1, 2, 3, 4, etc. Whole numbers are 0 plus natural numbers. Integers are negative natural numbers plus whole numbers. We have also seen what are rational numbers. These are numbers which are in the form of p by q. This figure says integers are also rational numbers. How? See, integers are minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. So these are not in the form of p by q, right? And we have learned that rational numbers should be in the form of p by q. So how integers are rational numbers? Because minus 4 can be written as minus 4 by 1. This can be written as minus 3 by 1, minus 2 by 1, minus 1 by 1, 0 by 1, 1 by 1, 2 by 1, 3 by 1, so on. 0 can be written as 0 by 1, 0 by 2, 0 by 10, 0 by 100. Anything, 0 by anything is 0. So all these are in the form of p by q, where q is not equal to 0 and both p and q are integers. So integers come under rational numbers. Similarly, whole numbers from 0 to infinity are whole numbers. These also can be written as rational numbers. And natural numbers. Natural numbers also, if you add denominator 1, all this becomes rational numbers. Thus, natural numbers, whole numbers and integers all are rational numbers. This chart is very important in class 8, 9 and 10. You take screenshot of this and keep revising this chart. Till now we have learned what are rational numbers. Now we will see properties of rational numbers. We can add, subtract, multiply and divide rational numbers. Out of these 4 operations, we will see which operations follow the following properties of the rational numbers. So first property is closure property. Closure property says that for 2 rational numbers, say a and b, the results of addition, subtraction and multiplication operations give a rational number. That means if we add, subtract and multiply 2 rational numbers, the result is a rational number. For example, if we add 3 by 8 with 5 by 7, we get 19 by 56, which is a rational number. Then if we subtract 5 by 6 with 1 by 3, the result is 1 by 2, which is a rational number. Now, if we multiply minus 2 by 3 with 4 by 5, we get minus 8 by 15, which is a rational number. Hence, for these 3 operations, addition, subtraction and multiplication, rational numbers follow closure property. Now we will see why division does not follow closure property of rational numbers. We know that 4 is a rational number and 0 is a rational number. If we divide these two, we get 4 divided by 0. So this is undefined. Thus we can say that for division, rational numbers do not follow closure property. Except 0, if we take any 2 rational numbers, then that will be closure property. For example, 1 by 2 divided by 2 by 2. This becomes 1 by 2 into 2 by 2. 2 gets cancelled. Answer is 1 by 2. 4 by 3 divided by 8 by 9. This is equal to 4 by 3 multiplied by 9 by 8. This is equal to 9 4s 36 and 8 3s 24. So this is a rational number. So in all cases except where denominator is 0, rational numbers for division follow closure property. Now let us see commutative property of rational numbers. For rational numbers, addition and multiplication are commutative. Subtraction and division are not commutative. We will see with examples. Commutative law of addition says a plus b is equal to b plus a. Let us take a is equal to 1 by 2 and b is equal to 3 by 2. So a plus b is 1 by 2 plus 3 by 2. So denominator is 2 and numerator is 1 plus 3 which is equal to 4. We will take b plus a. b plus a is 3 by 2 plus 1 by 2. Denominator is 2 and 3 plus 1 is 4. So a plus b is equal to b plus a. Hence we can say that in addition, rational numbers follow closure property. Now we will see for multiplication. So a into b is 1 by 2 into 3 by 2. This becomes 1 into 3 is 3, 2 into 2 is 4. b into a is 3 by 2 into 1 by 2. Where 3 into 1 is 3, 2 into 2 is 4. So a into b is equal to b into a. Thus we can say that multiplication also follow commutative property. Now we will see for subtraction. A is equal to 1 by 2, b is equal to 3 by 2. A minus b is 1 by 2 minus 3 by 2. This is nothing but 1 minus 3 by 2. This is equal to minus 2 by 2. Whereas b minus a is 3 by 2 minus 1 by 2, which is equal to 3 minus 1 by 2, which is 2 by 2. So this is minus 2 by 2, this is plus 2 by 2, which is not equal to. Thus, for subtraction, rational numbers do not follow commutative property. Now we will see for division. This becomes 1 by 2 by 3 by 2, which is equal to 1 by 2 divided by 3 by 2, which is equal to 1 by 2 into, we will reverse this. When we convert division to multiplication, numerator becomes denominator, denominator becomes numerator. So 1 by 2 divided by 3 by 2 becomes 1 by 2 multiplied by 2 by 3. So this is equal to 2 by 2, 3 is 6. Similarly, we will see 3 by 2 divided by 1 by 2. This is equal to 3 by 2 divided by 1 by 2. This is 3 by 2 into 2 by 1. This is nothing but 6 by 2. So this is also not equal to. Thus for division, a divided by b is not equal to b divided by a for rational numbers. Next property is associative property. Rational numbers follow the associative property for addition and multiplication. If you put examples and see, you will get the result. For addition, a plus b plus c is equal to a plus b plus c. So let us take a is equal to 1 by 2, b is equal to 3 by 2 and c is equal to 5 by 2. So a plus b plus c is 1 by 2 plus 3 by 2 plus 5 by 2. This is nothing but 1 by 2 plus 3 by 2 plus 5 by 2 is 8 by 2. So 1 by 2 plus 8 by 2 we get 9 by 2. Similarly, we will see a plus b plus c, that is 1 by 2 plus 3 by 2 plus 5 by 2. So this becomes 4 by 2 plus 5 by 2. This is equal to 9 by 2. So a plus b plus c is 9 by 2 and a plus b plus c is 9 by 2. So for addition, rational numbers follow associative property. Now we will see for multiplication. This becomes 1 by 2 into 3 by 2 into 5 by 2. And this becomes 1 by 2 into 3 by 2 into 5 by 2. So 1 by 2 into 3 5s are 15. By 2 into 2 is 4. This becomes 3 by 2 into 2 is 4 into 5 by 2. So this is 15 by 8, which is equal to 3 5s are 15 by 8. Thus we can say that for multiplication also, rational numbers follow associative property. Similarly, if you take 3 rational numbers and do subtraction and division, you will get a minus b minus c is not equal to a minus b minus c, and a divided by b divided by c is not equal to a divided b divided by c. Thus for subtraction and division, rational numbers do not follow associative property. Now distributive property. The distributive property states that if a, b and c are 3 rational numbers, then a into b plus c is equal to a into b plus a into c. Let us take a is equal to 1 by 2, b is equal to 3 by 2 and c is equal to 5 by 2. So a into b plus c becomes 1 by 2 into 3 by 2 plus 5 by 2, which is according to distributive property equal to A into B is 1 by 2 into 3 by 2 plus A into C is 1 by 2 into 5 by 2. Now we'll calculate both and we'll see what the result will be. This becomes 1 by 2 into 3 by 2 plus 5 by 2 is 3 plus 5 by 2. So this becomes 1 by 2 into 8 by 2. This becomes 1 into 8 by 2 into 2. So this is equal to 1 into 8 is 8 by 2 into 2 is 4. Similarly, this becomes 1 into 3 by 2 into 2 plus 1 into 5 by 2 into 2. So 1 into 3 by 2 into 2 is 3 by 4 plus 1 into 5 by 2 into 2 is 5 by 4. So this becomes 3 plus 5 by 4. This is equal to 8 by 4. Thus, A into B plus C is equal to A into B plus A into C. So, rational numbers follow distributive property. Now we will see identity property. Identity property says that any number multiplied by 1 keeps its identity. For example, you take 99. If you multiply 99 with 1, answer is 99. That means 99 if you multiply with 1 keeps its identity. That is, it becomes same number when you multiply by 1. So, we'll call 1 as multiplicative identity. Not only 99, you take minus 100. Minus 100 you multiply with 1, you get minus 100. 4 by 5, you multiply with 1, you get 4 by 5. 91 by 100, you multiply by 1, you get 91 by 100. So, when you multiply any rational number with 1, it keeps its identity. That means the result will be the same number. So, 1 is called multiplicative identity. Similarly, when you add 0 to a rational number, the result will be the same identity. So, 0 is called additive identity. For example, 1 by 4 plus 0 is equal to 1 by 4. 99 plus 0 is equal to 99. Minus 2.5 plus 0 is equal to minus 2.5. So, all these are rational numbers, and when you add 0, the result is same number, that is its identity. So, 0 is called additive identity. Please don't get confused. 0 is, if you add 0, the number will be same. So, it is additive identity because we will add. Similarly, if you multiply with 1, any number forms same identity. So, 1 is multiplicative identity. Now, we will see inverse property. Additive inverse property of rational number states that if A by B is a rational number, then there exists a rational number minus A by B such that A by B plus minus A by B is equal to 0. If you take a rational number A by B and if you add minus A by B, this becomes A by B minus A by B, so the result is 0. Like this, for any rational number, there will be a additive inverse number which if you add, the result will be 0. For 8 by 7, the additive inverse is minus 8 by 7. For 9 by 21, additive inverse is minus 9 by 21. For minus 4 by 5, additive inverse is plus 4 by 5. Additive inverse is nothing but just change of a symbol. Positive number becomes negative number and negative number becomes positive number. And multiplicative inverse property of a rational number states that for every rational number A by B where B is not equal to 0, there exists a rational number B by A such that A by B into B by A is equal to 1. So, multiplicative inverse is the result should come 1 if a rational number is A by B if you multiply with B by A. Numerator becomes denominator, denominator becomes numerator. Then the result will be 1. So, for 4 by 6, multiplicative inverse is 6 by 4. Because if you multiply both, you get 24 by 24, which is equal to 1. Similarly, minus 8 by 9. Multiplicative inverse is minus 9 by 8. Because minus 8 into minus 9 is 72, by 9 into 8 is 72. So, both gets cancelled and the answer is 1. Thus, additive inverse is just change of a sign, whereas multiplicative inverse is change of position, that is numerator becomes denominator and denominator becomes numerator. With this, introduction to chapter 1 rational numbers ends. Thank you for watching. Jai Hind.